Today topic is infrared spectroscopy. The infrared spectroscopy is a concerned study of absorption of infrared radiation. Infrared radiation స్టడీని మనం infrared spectroscopy అని అంటాం, which results in vibration transmissions. Here we observe the transmission of vibrations in infrared spectrum. The infrared spectra is used for the structure elucidation to determine the functional groups. We already know that the infrared rays are used to detect the functional groups in a molecule, and energy of molecule is equals to electronic energy plus vibrational energy plus rotational energy. Here the energy of molecules, which is equals to the energy of electronics and vibrational energy and rotational energy. Here these three comes together and that called as energy of a molecule. And the principle of infrared rays, which is, if any molecule, it is known that atoms or groups of atoms are connected by bonds. We know that the bonds are connected, used to connect the atoms and molecules. The bonds are analogs to springs. We have seen here. These are like spring-like structures and not rigid in nature, but because they have the continuous motion, so they are not in rigid motion. They maintain some vibrations with same frequency. They maintain the vibrations with the same frequency. So the infrared rays principle here comes to the natural frequency of vibration. The principle is natural frequency of vibration. And when energy in form of infrared radiation is applied, and applied infrared frequency is equals to the natural frequency of vibration. Absorption of infrared rays takes place and peak is observed. Here these are spring-like structures. They are not rigid and the carbon is contained 3 hydrogen groups, which is connected to the CH binding to another carbon atom, and another carbon atom is attached to the oxygen atom. It contains only one hydrogen group. Here the middle carbon contains 2 hydrogen groups, which are connected by the spring, and every bond of molecule in a functional group having the different frequency we have observed here. In pharmaceutical analysis, we use the infrared radiation wavelength is 400 centimeters to the 4000 centimeters inverse. We already know in UV ultraviolet radiation here what is the wavelength. If you know, mention in comments. And the regions like infrared, far infrared, near infrared. Near infrared is 0.8 to 2.5 and far infrared is 225 nu to 1000 nu. And the wave number is nothing but the number of waves present in which calculated from the wavelength. Wavelength we can see in infrared radiation, and the infrared radiation absorbing criteria is change in dipole moment. Dipole moment changes, and when we applied the infrared frequency, it is equals to the natural frequency of radiation. Otherwise, the compounds do not give infrared peaks. If we apply the natural frequency to the infrared radiation, then it gives the peaks. Here the infrared radiation vibration types given. What does they means? Stretching vibrations, bending vibrations, and yes, two types of vibrations are there, stretching and bending. Stretching means these are the vibrations which bond length is altered, that is increased or either be decreased, and this is two types, symmetrical and asymmetrical. And bending vibrations are change in bond angle. Here names explains that bending vibration bond angle changes and the bonds takes place within the same plane, and scissoring in which bond angle that decreases. If we cut the bonds, then it decreases obviously. And rocking out of plane bending. Here the two types of bending vibrations: in plane bending, out of plane bending. In plane bending means in the bending occurred in here we see that scissoring and rocking. Here out plane bending means wagging and twisting, twisted by using another atom plane and below the plane. And molecule, if a molecule contains number of atoms, the total number of functional vibrations are in a non-linear molecule or a linear molecule. This explains clearly. You can see the in plane bending and out plane bending. And here, but sometimes this spectral overlapping will be used in peaks. To give the peaks, we need some spectral overlapping. The instrumentation, here comes to the instrumentation which contains source. Source means what is the source? Here the nascent glober source are used. And sample, here the sample is like solid or maybe liquid, anyone. Monochromator means we have used the filters as a monochromator, which is made up of lithium fluoride, or prisms may be used, which is made up of potassium bromide and sodium chloride. And then detector, which detect the intensity of infrared radiations, like globe based cells, bolometers, pyroelectric detectors are used. Detector or plotter, the recorder or plotter are used to record the spectrum, infrared radiation spectrum, on white paper or any types of sheets. The instruments are contain types. They are which are contain the instruments. Here the